So, you guys will get 10 bonus points. Congratulations.
Cut for row. He coming there here absolutely livid about how I shouldn't tell him he's wrong. I was not supposed to tell him it's not chemical burns, but I guess it was like reverse psychology. He's like, oh, you just don't want me to know. He said, I seen the person with chemical burns.
Yeah, there's a few people that I got burned by chemical burns.
She had a cut on her finger.
And I believe the cut on my finger was chemical burns. I walked in all day yesterday, but they asked me, as soon as I walked out of here, a senior come right up to me and says, what y'all doing in there? I said, oh, I got burned by chemicals. You want to see? She said, oh my God, are you okay? I said, yeah.
And everybody's staring and laughing.
I love it. You guys did awesome. But you guys will get 10 bonus points. I'm going to tell you I'm going to give some bonus points to eighth period 2. I'm going to give y'all 10. You earned it. You did a beautiful job. Fantastic. Now, do me all a favor. In the next coming years, whenever I have 2 chemistry classes again, and I play this little game, and they're messaging you, do what my chemistry students did for me. Whenever they text me and they're like, what in the world are you doing in chemistry today? These kids are freaking out. They won't leave me alone. So that was really entertaining. Then the really funny thing is those people started playing games. It was good. All right, so let's address the question. What is the cost of 1 atom of aluminum? I'll be honest, there was one group in here, y'all were really, really close, had the right idea, you flirted with the idea, but like I said, you were at the train station, but you left your tickets at home. I had 2 groups in 8th period. One, I think actually somehow just magically typed the right stuff in the calculator and had no idea what they were doing, but they didn't put any units or anything, so it's like not happening. And then I had another group that they also were at the train station about to buy their tickets, bought the ticket, and then they said, oh, I don't need the ticket, and threw the ticket away. And I was like, I just walked off with a straight up poker face. I'm like, man, if they only knew. So, this is designed to get you to learn to think. I want you to learn how to think. I want you to think very critically. I want you to be a critical thinker. You need to learn how to think on your own, just in life in general. A perfect example of this is I was gone a couple years ago and I was installing a sound system at a church. When we were doing it, we had a plan. Well, when we had the plan, we didn't realize that underneath the stage, whenever they built it, which they didn't leave access to, which is another life lesson. If you're ever building something, think, I'm going to have to access under this or access this to work on it. Make sure leave room and leave access panels. So they didn't leave any of this, so we had to cut holes out of the drywall. Whenever we did this, we looked underneath the stage, and this is what the people that built the church did when they built the stage. No, they left all their trash there. So I'm talking bottles, I'm talking bags, I'm talking literally a stinking like trash bag of, there was a bag that had concrete in it that they used the concrete and left the bag laying there. So we didn't think it was going to be like that, because you never would have thought somebody that was a professional would do that we could fish a snake across and just tag to it and pull our wire through. That's what we thought. That's not what ended up happening. Whenever we looked at it, we had a problem. Whenever we tried to fish our... Wait a second. My wife's going to get mad at me.
It's 7:30, Mr. Hall. What did you do?
I did not tell her I made it safely.
Oh.
Yeah. She gets on to me all the time. She wants to know I made it safely, which I appreciate. My wife loves me. She's caring.
My mama makes me do that. I never do it, but she chews me out.
Yeah. My wife does too. So, we get in a situation, we're trying to run our snake across. If you don't know what a snake is, like, it's just a piece of metal
Frequency.
that you can just run across, and it's flexible. So it'll run across, and you can grab it and tag and tie to it, and then you can pull it. So you can fish things through walls and stuff without having to rip a wall out. So whenever we were doing this, we couldn't get the snake all the way over. So now we got a problem. And this is where critical thinking comes in. You got a problem, come up with a solution. So I came up with a solution because we could get it to where it was 9 feet from the hole that we were trying to reach on the other side that we had to fish the cable through. So I said, give me some of that speaker wire. I tied some speaker wire to a hammer, and I thought if I flew the hammer and I pull it, the claw on the hammer will catch the wire and pull it through. And they were like, yeah, it's a great idea. Well, the stage was about this high off the ground, so I couldn't get enough to throw it. So now I got to come up with another solution. So I'm sitting there, and this is where I came up with probably the most interesting redneck idea ever. I invented what I called the Kevin Hall Hickman-Duggar. The Kevin Hall Hickman-Duggar, I took a 2x4 and some electrical tape, and I taped my hammer to the end of it. So I have the claw of the hammer at the end. And then I drilled and screwed 2x4s together to keep extending it to the length I needed it. To where I could get it in there, turn it, and pull the hammer to me. And I got the fish tape, so I could actually fish the wire.
It sounds like a cat invention.
Yes, okay. But this is the thing. I came up with this because I can think critically. And that's the thing. That's why I tell kids, even if you're never going to use physics in your life, take physics. Why? You learn to think critically, analyze problems, work problems in there. I highly, highly encourage you to take physics. Yes, it's hard. Yes, it's difficult. Why? Because you have to learn how to think in physics. So, this is a little baby scale problem to teach you on that level. So, I'm going to do this quickly. So, the first thing is develop a plan. So, when you're asked for the cost of an atom of aluminum, the key to this is the word is atom. Well, I got to have some relationship with atom. There's nothing up here I can use to get me to atom, which is why you have to take your sheet of aluminum foil and put it on a scale back there and get a mass of it. So most of y'all got a mass of 1 gram. Now I can take this 1 gram of aluminum and I can take it to, let's do that. I can take it to moles, then I can take it to atoms. So then what I can do is once I've done that, it tells me the amount of atoms in a sheet. Once I have the number of atoms in a sheet, that's when it all gets interesting. Because
But it's already
it's true. You have to draw a relationship here between the sheet and the roll. You have to know how many sheets are in a roll. Now this is where everything is set. You have to do a mole conversion. You have to find the amount of atoms in a sheet. You have to draw a relationship to how many sheets are in the roll. There's no getting away from that. From this point, there's more than one way to skin a cat.
Poor kitty.
And there's any way you want to take it is fine. I've seen some very interesting ways and it works out as long as you end up with the right thing. So the first thing, I'm going to look at is finding my relationship with the sheet and the roll. I need to know how many sheets are in the roll. In order to do this, this is why it's such a great problem. You have to learn so many things and use so many things you've learned in this class. Centimeters, meters, millimeters. There's a problem. Units are all different. We got to convert them. So, like I said, I'm going to do this quick. That puts that into meters. That's already in meters. Now this is in meters.
How'd you get that quick?
I've been doing it a while. So,
He just blew his coal on.
Yeah, let's get back to the bag.
Well, let's do this problem real fast. We ain't never done it. It just says, alright, we're done.
Oh, that worked for me yesterday.
okay. Now I got to find a relationship between them. What's the simplest relationship to find? Area. So, area in the sheet.
It's lead times with.
I get the area of the sheet to be 0.0225 meters squared. Area in the roll. That's a big roll. 6.9312 meters squared. I need to know how many sheets are in the roll. So all I need to do is take the area of the roll, divide it by the number, by the area in the sheet, sorry. So I do that. I get 308.0533. I don't know what you are thinking. How you need units? Actually, I don't. That's just a ratio. Meters squared cancel. That's the magical number. Now I know how many sheets are in the roll. Now I need to know how many atoms are in a sheet. Once I have how many atoms are in the sheet, then I can figure out how many atoms are in the whole roll. Then I know how much I paid for the whole roll. I can tell you how much one of them cost. Yeah, right. So, set it up. I have 1 gram of aluminum. Set over 1. I need moles of aluminum. So I can divide that by grams of aluminum because I'm leaving grams. Grams of aluminum on the periodic table is 26.98 grams per mole. So, grams of aluminum cancel, leaves me with moles of aluminum. Now I gotta get to atoms, which I'm gonna use a special number, Avogadro's number. So, atoms of aluminum. Divide that by 1 mole of aluminum. What?
Talking myself.
I will say this, if you're totally lost and you're wondering where all this came from, let me tell you what this is. This is mole conversions and we spent about a week on that. If you don't know how to do this, here is your first wake-up call to, hello, they're coming back. They will return and they will bite you in the booty. It will hurt. For the love of God, come see me. We do them, okay? Very nice. Okay, anyway. Back to it. So, 1 about 26.98 times 6.022 times 10 to the 23rd power. And I get 2.2320 times 10 to the 22nd power, and that's atoms of aluminum. But this is how many atoms of aluminum are per sheet. Now I know how many atoms are in that within 1 sheet. I now know how many sheets are in the roll. I need to find out how many atoms are per roll, right? So, in order to do this, we need to multiply. So this is equal to 6.8758 times 10 to the 24th. That is the amount of atoms per roll. So that's how many atoms of aluminum are in a roll.
You still ain't done?
No. Now, my favorite thing is how many people looked at me yesterday and was like, trying to trick us. It costs $2.29 per atom. And I went, really? Well, if that's true, I definitely need to invest in some aluminum stock. Because that's pricey. Because how many atoms are in this? That's how many atoms.
Imagine going to the county back. I want 5 of these.
The cost of the atom cannot be even close to the cost of the roll. Look how many atoms are in the roll. Can't even be close. Which leads us to the last thing we're looking at. We now know how many atoms are in the roll. We want to know the cost per atom. So we take the cost of the roll, $2.29, divide that by the amount of atoms in the roll. To find ourselves our answer. So here is the cost of an atom of aluminum. Are you ready?
I already looked this up, so I don't know if you're right.
$3.3305 times 10 to the negative 25 per atom. Now, here's the thing, is whenever I'm checking these answers in class, the fun thing is if you look up the right one, you see there's a range, because it's all about how much the cost of the roll is, and it's also about, like some of y'all had a corner tore off, and you got 0.9 grams instead of 1 gram, which wasn't a big deal. You would just add a smaller number here. The range is what's important. It falls between 1.0 times 10 to the negative 25 per atom up to 6.0 times 10 to the negative 25 per atom.
Not bad.
Now, here's the thing. I know it's difficult, but this is where I'm wanting to get you as a student. This is a good problem. You had to use a lot of stuff I've taught you in this class. You had to use metric conversion. You had to use mole conversion. And the big thing was you had to draw relationships between things. If you can get to where you can do this, you will be successful at whatever you want to do. So if you want to go teach English, perfect. It'll be great for you.
Oh no, Lord.
If you want to go be a doctor, perfect. Problem solving, drawing relationships, whole time. It's going to work for you, but you need to let it work. Okay? This is what I'm trying to do. We're trying to grow you. As I say many times, me no makey snowflakes.
Because it's summer, it's actually fall.
You have brain in your head as well. You don't always have to use Mr. Hall brain. Trust me, you don't want up here. It's a weird place. It's like 1 minute got a country hillbilly, and the next minute you don't know what accent's gonna come out. Any questions here? Perfect.
Astonished, really.
Do what?
But just astonished, really.
Prop Bob, right?
Rob Bob. Rob Bob is fine.
No, you showed us
Rob Bob has
the,
something on to do.
you showed us the mother of the belly of the beast.
The moth Rob Bob.
No problem. No problem.
Okay, so we left off, and I showed you my pretty. Did I show you all my pretty lights?
Yeah, but you just showed them. Well, we got two
Like
of
two
these.
of them.
Yeah, we got two of them.
all the rest.
Okay, I will make it up to you. I ain't gonna make it up to you today because it's gonna waste time for me to get it out.
It's okay.
It's not okay. We must roll on.
Yeah, Dalton, it is not.
We must roll on because we have material we must cover. Why? What do you have on Friday?
It's Friday or
Boom. What?
it's Friday or first time week's exam. I knew we did. You guys already checked in. We did. I'm gonna scream at her.
Listen,
We said
I really don't go with that, especially in chemistry, because everything you take, and once you learn it, don't forget it's all for a game, it doesn't matter.
It's all really a chapter test at the end of the day.
Pretty much. So, I want to take you to one of my favorite things.
Alright.
Listen, do not be scared. There's nothing to be scared
I
about.
want them all.
I'm going to be honest with you. This will probably end up being one of your favorite things.
Are you sure about
This
that?
work,
I am, because if you can follow the pattern, you will look at me, and I've had students before beg me. They're like, Mr. Hall, can we please just take a quiz on this, please?
Will you
I
let us
understand
take a
it.
quiz on it?
Huh?
Will you let us take a quiz on it?
Absolutely, I'll put some other stuff on it too.
Oh.
So before we do this, Mr. Hall must give you a gift.
Is it a pattern?
Is it the
Follow?
7 diatomics?
They are a part of it, yes. This is a gift that just keeps giving.
Are you sure about that?
I love periodic tables. Put the right now. You were going to take a periodic table.
No, I'm ruining the Christmas.
You guys are going to take a periodic table. Okay.
We don't get a choice.
Me too. I keep all mine in there.
Every test, we get one, I just start writing something.
There you go.
I must say, I'm a little sad. You guys have learned me so well. My gift that I keep on giving.
Mr. Hall, we already have 100 of them.
Well, we don't have enough.
You cannot wallpaper your room yet.
My mother would kill me if I wallpaper all this.
I like to keep these.
That'd be awesome.
I like my walls are called, the paint is called cup of coffee, and I like those. So I don't want to get on paper from them.
What if you took
You
your
can carry on.
periodic tables, put them in a cup of coffee, and then put it on your wall?
You want a cup of coffee out of these?
Exactly, dog.
Oh my
You just
God.
periodically
Origami.
coffee.
Okay, here we go. What I've given you, you will use in a moment. As of right now, you know you use it. Okay,
Darn.
I know. So we must address one of the wonderful things that classes typically really love doing, and that is
Bulk version.
the electron configuration.
Oh, yeah. I didn't do it.
I like the bulk version.
What's it, 26?
Yes.
Thank you.
Welcome. So the electron configuration. When you're looking at electron configuration, there's 3 different types of them. I'm going to tell you them. We're going to cover them one at a time. The first one is orbital notation. The second one is actually called electron configuration. I know, confusing, just bear with me. And the third is noble gas configuration. I want to look at you and tell you, when you're looking at these electron configurations, there is a pattern. You must learn the pattern. You must learn the pattern so that you can do what I'm about to do. We care now about the electrons. We must know where the electrons are, how they're going, and it all revolves around field order.
Oh, yeah. My neighbor.
Yeah, makes perfect sense. Worry about the field order, Mr.
I
Paul.
thought you said Delores, and I was like, yeah, that's my neighbor.
I heard Leroy.
I think it's Philroy.
No, we're talking about field order.
Right there.
When you look at the field order, this is your field order. I don't expect you to be me, but I do expect you to get to know it. 1S, 2S, 2P, or not 2P. That is the question. 3S,
I like PF.
3P, 4S. Then things change. We go 3D.
Ooh.
Woo, yeah. Then we go back to 4P.
Not that.
Then we go 5S, 4D, 5P. No, I'm not done yet.
1S.
So then we continue.
Oh, Jesus. Stop it.
It gets freaky now. We go 6S.
Sorry.
Then it all gets really freaky. Then we go 4F,
What the?
5D, 6P. Then it gets freaky again. We go 7S,
I'm never going to
5F. There's a pattern. Trust me.
I don't like
What's
that.
6D,
I'm just bored. Yeah, I want to write
7P.
I'm writing down like 3 numbers. But
This is your field order.
Yes.
Now, I've already taught this 8th period because we had a 3-hour early dismissal. So I had them and I didn't have you. And I had a very good question. And it really lets my students tell me what they think about my heart. And apparently, they think I'm the Grinch. They think I have no heart. Do I expect you to memorize this?
no.
I
Say
expect you
no.
to learn a pattern to how to get it. I can do this from memory because I've done it so long. I don't expect you to memorize that. Dear God, if you're going to sit at home and try to memorize that, best of luck. I'm going to show you 2 methods on how to get it.
Challenge?
Yeah, that's a challenge.
Consider it a challenge.
Fight.
We don't condone that.
Okay, so before we go into methods on how to find your field order, I need you to understand there's 3 set rules that define where these things and how these things are going to work. So the first and foremost, the one you will look at first is the off-ball principle.
The softball principle?
Off-ball.
Oh.
Softball?
Off-ball.
It was a weird name.
I love all
Stop it.
Yes,
Has to be German.
Probably is. So you need to know the rules for this. The off-ball principle states an electron will occupy the lowest energy level possible. Yes, very good, very good. Pretty much, break it down in simple terms for you. Electrons are lazy. They're going to go the shortest distance they can. So they're going to go into the lowest energy levels they can. You remember when we did the ground state and excited states, and I did those circles, and I did n equals 1, n equals 2, n equals 3, and I was like, these are the energy levels. Those are where the electrons are at. Those electrons are going into those, and they'll go into the lowest one that they possibly can. So, next one. Next one will be your favorite one. The poly exclusion.
Oh, it's poly, not like poly, like more than one. It's Pauletta.
Yeah.
You're right, Don.
The poly exclusion principle. The poly exclusion principle will be your favorite one
Why is that?
because it states that no two electrons within an atom can have the same four quantum numbers. Now this is where I typically bring up in the class. In this, I do this lesson first because you learn a pattern and it exposes you to things that you'll get to see, but you just have to accept them for right now. I'm sorry it's like that, but it is how it is. It is what it is, all right?
See how it we do.
How do you do? So you just got to accept it at this point. I'm going to teach you it later on, but right now you're just going to have to accept it. Like S, P, D, and F. Just accept it. Now, the last rule is the one that really brings in the whole, just accept it. And this is the big one. It's called 100.
Sounds like
100 states. Orbitals. Do you know what orbitals are? No. What?
I don't, I was gonna take a big guess and just say that it's electrons and it's orbiting the.
No, but you're flirting with the idea. We'll discuss this later. This is the one where I'm saying, just accept it for right now, okay? I tell you it tomorrow. But the orbitals, the same energy level. Will all get one electron first before getting the second. We will discuss this tomorrow on what we are discussing there. But I want you to learn something. I'm going to show you the first method that I do not like in order to how to find field order. I hate this method. But I teach it because a lot of kids like it. So how to find the field order. So you're going to make rows with columns. You're going to make columns here of these things. So it's a 1S, 2S, 3S, 4S, 5S, 6S, 7S. Then from here we're going to go to P. Now P's different. P starts at 2. So there's not a 1P, there's a 2P. Because it's 2P or not 2P, that is the question. So I marked it down, we went across the curriculum, I referenced some literature.
Urine.
That sticks in biology, it sticks in science. Okay, D starts at 3. 3D, which is how we like our world. 4D. 5D.
Oh, I see your pattern now.
6D. There's not a 7D. Then F starts at 4. 4F. 5F. This is the most important part if you're going to use this method. You have to set this up properly. You have to set this up how I have it. If you do not set this up properly, you will get your field order wrong, and you will be wrong. This is why I don't like this method. Don't know if we're going to make it through it or not. All you have to do is draw diagonal lines through it, and it's going to lead you through. 1S, 2S, 2P, 3S, 3P, 4S. Somebody watch over here and tell me if I mess up. 4S, we go 3D, 4P, 5S. 4D, 5P, 6S. Then I go 4F, 5D, 6P, 7S. And it ends off with 5F, 6D, 7P. Did I get the same thing?
Uh-huh.
This is the first method for how you can get the field order. If you like this, use this. If you don't worry about it. Tomorrow I'm going to give you my method that I like, that I follow, that I use. And it's all on that periodic table. What do you get on your quiz?
The periodic.
So I'm giving it to you, you can follow the patterns.
You're probably going to take off the thing that you use for a pattern.
Impossible.
All right, we'll take where it's
Yeah, the power is in your hands.
Why can't you make it?
Because I can't make kids sign up. You have to sign up. And like when you go in there, if the counselors are going through all the classes and they tell you these are your options for science, and you do not hear AP Chemistry, you should go. What about an AP Chemistry class? We want AP Chemistry.
How would you do AP Chemistry? It kind of scares me, honestly.
Like this.
trying to make you
The harder.
No, it would be exactly what this is.
I'm sorry, but I wouldn't sign up for that because I just barely passed the
this part.
Oh yeah, but you got 9 weeks. Don't worry about it.
But still, you never met my parents, thank you.
So I can just take the class again, basically.
The parents.
Just take you credit for it.
Okay,
That would be dope.
I want to show you the second method. So I showed you the diagonal. And that's how the field order is going to go. But I want to show you my personal favorite, and the periodic table is built and set up for this. This is actually the reason I use this periodic table in this class. I give it to you on your quiz. See? You always have periodic table. So if you use this method, guess what you always have? You have the field order for you. Use the method. The first piece of information you need, you're going to feel like you're going to prison today.
Well, that's not good. I don't want to go to prison.
You need to know the blocks of the periodic table. The first one is the first 2 columns. Welcome to the S block. The second one is columns 13 through 18. This is the P block. I want to instruct you on something. There is an exception to the rule. Helium. Act as if helium don't sit here. Act as if it sits here. See?
So don't include it in our P block?
It is actually not in the P block, it is in the S block. Now, the third one, columns 3 through 12. This is called the D block. And then the last one, I like to refer to it as the solitary confinement for the periodic table. It's the F block, lanthanides and actinides. So this is F block. Now, this is set for you whenever you're looking at doing your fill order. I'm going to tell you the why. I can get my camera set right. I have to leave it crooked for now. I'm going to tell you as to why. This is set for you in order to use. Once you know the blocks, then you know the letter that goes for the orbital. So the PT for fill order. The periodic table for the fill order, the block tells you the letter. The row tells you energy level. So the block will tell you whether it is S, P, D, or F. The row will tell you what the energy level is. Energy level stands for N. I'm going to give you a formula to help you with this. Prepare yourself. It's quite possibly one of the most complex and complicated formulas you will ever see in your life. For the S and the P block, N, which is your energy level, equals rho. And by rho, that is not 3 individual variables. That just stands for rho off the periodic table. Very complex, I know. For the D block, this is where it gets confusing. This is where the complex stuff in chemistry comes in. N is equal to the rho minus 1.
Hello, my name is Hannah Evans. I'm a Westside Raised crew member. I support Red Ribbon Week. I would like to share some fun facts about drugs and tobacco use.
Fun fact?
Smokers suffer shortness of breath almost 3 times more often than non-smokers.
That's not fun.
On average, adults who smoke cigarettes die 14 years earlier than non-smokers. Always say no to drugs and tobacco use. It's a great day to be a renegade.
All right, the F block. This is where it gets real complex, okay? Everybody bear with me. If you haven't picked it up yet, I'm being extremely sarcastic. In.
Oh, it's pretty hard. You should have seen me in good old STEM trying to figure out rows and columns. I'm not doing too good. I'm pretty bad at that. I remember Ron Nicole, but which way's Ron and which way's Cole?
How do you row both? When you row,
Gently down the stream.
do you go vertical or across? That's the row. Columns. Straight now.
I'm trying to think of columns as like Coliseum. Big thing that's Coliseum, which is big.
N equals row minus 2. This will give you the number that goes with it. The block will give you the letter. So, I need some assistance. I need a volunteer.
Dang it, don't come here.
Please come to the board.
Go, Carlos.
Yay, volunteerism.
What?
Volunteerism. Volunteerism.
Community service.
Community service.
No, you just have to write what I tell you to write. Okay? You're going to write under this so it looks good for our notes. Okay?
We have one.
All right. So, we are now going to use the periodic table to get our field order. Yeah. Okay. So you know the box. I got to take this off so that I can draw it. On your periodic table, here's the thing. It's all built for you. What's the rows on the periodic table? First, second, third, fourth, fifth, sixth, seventh. There's 7 rows. For those of you in the room that want to get, Mr. Hall, you forgot to license an Arcanoid series.
I wasn't going to say you forgot it, but I was going to ask about it.
Notice something on your periodic table. Look after number 56, barium. You see that box there? It's got 57 through 70. Where do you find element 57? At the lanthanides. Wow! How about that?
That's crazy.
These actually stick right here. But the periodic table would look really weird if we did that.
Oh, they go in that row?
They go in that row. So which row is the lanthanides? 6. Very good. Actinides are 7. This is important. Make sure you got it. See? Now, it's all based off what you're driving through. I love the periodic table because it's used for us so that we can have a roadmap. This is your roadmap to success.
I thought they were robots. Oh.
Okay, what row am I in? Starting off. 1. What block do I go through?
Hydrogen.
At what block?
1.
Block.
S.
There we go. I went through helium 2, so is that P block?
No.
No, it's
S.
S block. So we went through the 1S. Now, I'm in the second row. What do I go through?
S.
So 2S. How do I know it's 2S?
Second row.
I'm in the second row and I went through the S
I
block.
thought the same thing at first, but it's okay.
Sarcasm. All right, what row am I in?
I really thought it was 2 because you only put the lines of the 2.
It's literally 7:45 in the morning.
So, second row, 2P. 2P or not 2P?
I get this.
Depends on the
Same thing you showed us yesterday.
You catch it up fast. Hey, third row.
Uh-oh, we're going through.
Oh, come on. You got to make it sound like music to my ears.
Yeah.
Okay, we definitely need music classes.
I'm off too. I've not had one music class since I've been in the building.
Music class is making me want to
3P.
off with myself.
Everybody together?
3P.
Thank you. I love it. Even the accent.
Not 3P.
3P. How? What? Somebody tell me, why is there not 3D there? Why is there no 3D? Why we no go through 3D?
Because there's no D.
You didn't go through 3D
D is
yet.
not there.
You haven't went through the D block, have you? No. So it's 3S, 3P. 4,
No, S.
4Fs. Now, here's where the change comes in. Remember the rule. When you're trying to get the number in for the D block, you subtract 1 from the row. I'm in the 4th row and I go in the D block. It's 3D. How'd you get 3D?
Subtracted 1.
From the row, which gives me the number 3, and it's the D block, so 3D. What's next?
Wait.
Okay.
Wait, hold on. 4D. Why? Why? What are you subtracting why? I need to know why.
What? We need you to repeat everything you just
I
said.
need to know how it works, why it works.
Okay. I'm gonna try. Okay, remember how I told you there's some things in this you just gotta accept right now? You just have to accept this right now. Because in the next thing I teach you, you're gonna use those formulas but in reverse.
In reverse.
Don't freak out about it, just accept it.
Okay, so, but what number do you subtract? So you subtract the row?
The row.
Okay.
So,
Okay, well then
That'd be only one.
So it's just subtraction, would you?
okay, we're good. I got it.
Okay, so then we go 4P. Then after 4P, we're in the 5th row now, so 5S. Now, this is where it starts clicking. You start seeing a repeating pattern. I'm going back in the D block. What does that mean I got to do to my row? Subtract 1. So what is it?
4D.
It's 4D.
Okay, that makes sense.
So for every one of the D blocks, you would just subtract 1.
You're going to subtract 1 off that row. Exactly. I'll go ahead and
Think
I'll...
of it as paying a toll. Every time you stop at D block, you gotta pay a toll.
Exactly. That works perfect. I love it. This is the way to look at it is, the reason this is happening is because the octet rule. We're not going to cover the octet rule until we get to bonds. We ain't there yet, so I don't want to teach it to you and confuse you and you'd be like, well, why does any of this even matter? It works, the octet rule works in bonds, so don't worry about it right now. Yeah, you in AP biology, you know. All right, 5th row, where I go?
5P.
I'm not an
5P.
3D, thank God.
After 5P, we get, we're in the 6th row now. I'm going to tell you, when you get to the 6th row, it gets freaky.
Oh,
So 6th row,
6S.
6S. Where do I go after 6S?
6S. You go down to
4A.
4A. 70. Because it's supposed to be there, but it's not.
I come down here, I'm still in the 6th row, but I'm down here in the lanthanide. That's why I love this periodic table so much. It leaves the blank here for you. That blank, I give it to you as a reminder. You need to go to the F block. So I'm in the 6th row. What's the rule with the F block? N equals?
Subtract 2.
Subtract 2. Row minus 2. So it's the 6th row.
4F.
So it's 4F.
That's not hard at all.
I told you, you'll like these. These are patterns. Learn the pattern, you'll master this.
I like this way better. It involves all
Then you
colors.
get our periodic tables back and they just got one thing.
Now, where do you go after F?
Go back up to.
You go back up. Notice something. Look at the end of the F block. 70, 71. The numbers tell you the order. So now I'm in the D block. What are we at?
5S. No. 5D.
5D. How'd you know it's 5D and not 5F?
It's in the middle.
It's in the
In the D block.
D block. It's that simple. You're in the D block.
Minus 1.
Now, what comes after 5D? 6P. I should have students write on the board a lot more often. That looks a lot better than my handwriting.
Not everybody's does it.
It's just Carlos. You got lucky.
She volunteered.
Extremely crop right there.
Right? 6P. Let's go. After 6P, we're in the 7th row, right? So which block we go through?
7S.
7S. Where we go after 7S?
Down to the, down to 89.
Down here. We're going back to the F block.
So that'd be 5S.
5F. Beautiful. Yes. Look at you. After
7P.
you go 6D, then you all are already ready to go. You'll say
7P.
7P. You're out of the periodic table.
We want the 7-piece chicken dinner.
5F.
It's not F.
Wait. Yeah, 7P. Sorry. You got it. Hey, that's how I like to use it.
And that's it.
Whatever field order method you want to use it. But compare that field order that's on the board right now to your field order I gave you yesterday.
So is it really this simple?
I don't even remember the one yesterday. so
It's
don't
this
worry about
simple. The only thing is you have to be able to remember the 3 rules and determine the difference and know the difference between the 3 types of configurations. The reason behind that is you have to be able to look at me and know, I'm going to ask you, I want an orbital notation, I want an electron configuration, I want a noble gas configuration. That's what we're going to start doing now, is I'm going to start giving you these, and we're going to start doing them. Every time I give you one, though, you're going to be like, when I give you orbital notation here in a second, you're going to be like 8th period was yesterday. You're going to be like, what? Why?
There's scientific notation, but orbital.
So, just trust the method. It works. Wow. This is like way crooked right now.
I mean, this part's simple.
It is. Where I switch from desk to desk. There we go. All right. So you have your periodic table marks on. You got it ready to go for you. There's our field order. Now I want to introduce you into your first type of electron configuration. The first type is the one that you will learn that you're going to hate.
Oh, see, Mr. Hawk, you
Love
did
learning to hate things.
You're going to hate it. Have y'all ever solved equations by graphing?
Oh,
Then if you learn right after that, you solve equations by elimination or substitution, and you go, why did we graph? It took
yeah,
forever.
that stuff's annoying.
That's us right now.
I'm going to be honest with you. This is how you're going to feel on this. I'm going to do the orbital notation. You're like, why did we do that? And there's a reason.
I'm glad I haven't my first period. It really gets me going for the day.
I've had some teachers look at me and tell me, it's like, I can't do you. You have too much energy in the morning.
I got stuff going on. Gets me going. Especially for second and third period.
All right, orbital notation. I've changed how I define this in a way that I believe your generation will understand it better. Orbital notation.
Notation
What is that?
Circle. It's circle notation.
It's orbital notation. We can't change the name. Okay, so orbital notation uses underscores.
You ever wonder like who comes up with these names and stuff like underscore?
I don't, but all y'all understand it because yesterday in 8th period I was like dash.
Taylor Step comes to the DLC, Taylor Step.
Bye-bye. So I was like, do I say dash, which I've normally always said, but then I was like, underscore would fit better. Do y'all understand what I mean with underscore? They're like, yeah.
Yeah, dash the hyphen.
Yeah, exactly, and that's where the confusion
Yeah.
was. There was this gap between my generation and yours.
Yeah.
It's okay. So it uses underscores with the energy level abbreviated as N and block number, block letter, sorry, to label / show our orbitals. So what I'm saying with this is, I'm going to do this. I didn't do this in 8th period. I feel like this will help you a little bit. So I'm going to choose a couple from up here. Hopefully this works out nicely. So I'm going to do a 1S, 2P, a 4D, and a 5F. I'm gonna write them out over on that side, but I'm gonna keep defining for right now. Yes, ma'am.
Alright, just want to remind y'all that West Virginia Dance is here, so you'll be going down at 9 o'clock. Good behaviors are expected, and no nonsense down there.
You wanna know what I've told my classes? Have you ever watched The Game Plan?
Yeah.
Have you ever
They're
watched
off,
Tooth
yeah.
Fairy?
Who?
The Tooth Fairy?
Oh, yeah.
Yeah, great movies, right?
Yeah.
Yeah, the Dwayne "The Rock" Johnson rolled around in a bunch of tights. So these men down here, they're closer to being Dwayne "The Rock" Johnson than we are.
That is true. That's a good way to put it.
Okay, so
I don't know why people hate them anyway. I love watching them do that stuff. That's crazy. I don't know, it's just me.
Owen's gonna jump out there in a pair of tights.
If they would give them to me, I would. I promise you I would.
They asked for a volunteer, we're all gonna just start chatting.
I'll go out there, I'll put some ties on, and I'll show them how to work.
Yeah, he's gonna get his swag walk going.
What's up?
Mr. Hall, you can go too, you need to practice.
Oh, that ain't gonna happen. They ain't gonna put this fat guy in some tights. Like, woo, man, that's 3D.
Oh my God. You're so
All right.
funny, Mr. Hall.
Can't laugh at yourself who you're going to laugh at, all right? All right, orbital notation. So the use of the underscore. This is the important thing. I'm going to write it in purple. Kids tend to struggle with this.
Purple means important.
I like red as important. I hate red.
I'm just saying that here in a second, I'm going to show these to represent them to you, what they look like. So I'm going to do a 1S, a 2P, a 4D, and a 5F. And I chose them randomly, just so they look different, so you look and say, oh, okay, that's what you're meaning. So I'm going to define it, then I'm going to show you what it looks like. Uses arrows to represent electrons, and the key is they must point in opposite directions. Well, we're going to make a note here. You can kind of look at this and be like, students ask why. Somebody asked me why. Why? Thank you. They must point in opposite directions, and I'm going to foreshadow the last quantum number we're going to discuss. It's probably going to come next week. Because what do you have Friday? Quiz. So, opposite directions. Why do they do this? To represent the natural spin of the electrons. Now, the question is why are they in opposite directions? It's all about the spin of the electron. Why is the electron spinning? What is an electron? Negatively charged subatomic particle. Beautiful. Yeah. Negatively charged subatomic particle. We put them in the same space together. what do like charges do? They repel. So we got a problem. These electrons are going to want to repel each other. There's this cool thing that happens when you take something, electrical charge, and you move it. Like you spin it, it creates a magnetic force. So what these electrons do is they spin in opposite directions. And when they're doing this, it creates a magnetic attractive force that overcomes the natural repulsive force of those electrons, like charges. Isn't that cool? Yeah, man. It's like awesome. All right. Now, I know what you all are thinking.
Where's Dalton?
Not what I was thinking. What is he talking about? So I want to show you how they look.
He's purple. I hope he's not purple.
Don't worry about
You hear them, Mr. Hall?
Nope.
They're being very mean. They said Dalton is at the hospital and he's purple.
That's sad.
See?
No, no, that's not it. At the hospital.
Is he really at the hospital?
Yeah.
Yeah, it's for his mom.
Oh, God.
I didn't know that.
I didn't either. I was wondering where he was though.
I didn't know that.
I feel
I know we had to take her to a doctor's appointment yesterday evening. Maybe she got there and
I think
said.
you put me Dalton.
I think we should also not be there. So we love you, Dalton.
He can hear it.
Yeah,
Yeah,
we
it's
can
all
hear
good
it.
on there.
really terrible. What's this? So then, let me show you how these look.
Nice.
So I want to do a 1S. Here's the thing. Here's the thing when you're looking at these. You got to know how many orbitals go with it. So I want to look at the block / shape. And the number of underscores.
What?
So you know the blocks already. You have an S block, P block, D block, and an F block. The number of underscores that go with it is important. Kids struggle with this every year. So I want to make sure you get this. The S block has 1. He was number 1. The P block has 3. The D block has 5. And I bet you can predict what the F block has. 7. So this is kind of what they look like. So I told you I was going to draw these out over here. So I want to do a 1S. How many underscores does an S have? So you put a 1 underscore. Below it, you put the number for the energy level and the block. So 1S. Then we're going to do a 2P. How many underscores does a P get?
3.
So 1, 2, 3. Go in the middle of where it's at. So this one's the middle, right? That's where you label 2P. Then we got a 4D. How many does D get? 1, 2, 3, 4, 5. Where's the middle?
3.
So 4D. And then you got F, and I chose 5F. How many does F get?
7.
7. 1, 2, 3, 4, 5, 6, 7. Where's the middle?
3 or 4, you pick.
4. There's 3 on the left, 3 on the right. So 5F. So this is what it's going to look like. I'm going to go ahead and tell you, many of you are going to do your arrows like this. That's fine. I do my arrows like this because it makes it faster.
That's just the 1. How much faster can you get drawing an arrow?
Promise. When you're doing these, you're in the F block, you'll be happy. Now here's the thing. When you're doing these, you've got to remember Hund's rule. Every one of those orbitals receives one electron before it gets the second. That's an orbital. That's an orbital. That's an orbital. It's the same energy level. So what it's saying is this will receive an electron. Your next one doesn't go here, it goes here. Then you come back and fill it. Last thing I want to say, you always start pointing up, and even if you don't put one in the last orbital, you still have to show that orbital. So like the 4D I have here, I still have that 5th orbital there, even though there's not an electron. It has to stay there. You have to represent it.
If you don't put anything in it.
You don't put nothing in it.
You don't have
Hey, tomorrow we'll start up, actually working some more implementation problems. We'll get in electron configurations, may hit noble gas configuration.